Section 3.2, solving systems of linear equations by substitution method. So here are your steps. Step 1, you're going to isolate one of the variables from one equation. Step 2, you're going to substitute the modified equation from step 1 into the other equation. Step 3, solve the resulting equation. Step 4, substitute the solution from step 3 into the modified equation from step 1. So this is how it's going to play out. So let's look at example 1. It says solve the system. We have 3x minus 2y equal to negative 7, 6x plus y equal to 6. When we look at our two equations in the system, go for the one that has one variable equation with a coefficient of 1. So when I look at my problem, I'm going to start by looking at my equations, and I'm going to pick the second equation to modify. So we're going to take the second equation and solve for y, and it's going to become y equals negative 6x plus 6. So step 1 says isolate one of the variables from one equation. So I took the second one since it's easier to solve for y. Then it says substitute that solution, that modified equation, into the other equation. So I'm going to take my first equation that we didn't change. So I'm going to write 3x minus 2, and then in parentheses, I'm going to stick in what y is equivalent to. It's negative 6x plus 6 equaling negative 7. So now I have a new equation to solve with only the variable x involved. You're going to distribute to become 3x plus 12x minus 12 equaling negative 7. Then we are going to combine our like terms. So 3x and 12x is 15x minus 12 equaling negative 7. Add 12 over. You have 15x equaling 5. Divide both sides by 15. So x is equivalent to 1/3. We have a fraction. So I know what x is equivalent to. Now I need to find out what y is equivalent to. So remember, you had that modified equation of y equals negative 6x plus 6. So we're going to take our equation, y equals negative 6x plus 6, and we are substituting in for the x. So y equals negative 6 times 1/3 plus 6. If you take 6, negative 6, and split it 3 ways, you get negative 2 plus 6. So y is equal to 4. So our solution is 1/3, comma. Okay, example 2 says solve the system. We have negative 3x plus 4y equal to 9, and x equals negative 1/3 y plus 2. So in this example, they've already told you which equation you're going to use for your substitution method. They told us x equals negative 1/2 y plus 2. So we're going to substitute this entire equation right here into the x position of the first one. So we're going to write negative 3 parentheses, negative 1/3 y plus 2, close it, plus 4y equaling 9. Okay, we're going to apply the distributive property. So think of the whole number multiplying to the numerator. So I'm going to say negative 3 times negative 1, that's positive 3 over 3. I just slid my denominator over with a y. Negative 3 times your 2, there's my negative 6, plus 4y equaled 9. Yes, you can reduce this from the beginning. I just did this so that for individuals that cannot see the fractions, it's easier to do this. So now we see 1y minus 6 plus 4y equaling 9. We're going to combine our like terms. So 1y plus 4y, that is 5y minus 6 equaled 9. Add 6 over. So we get 5y equaling 15. Divide both sides by 5. So y equals 3. So we know that the y value is a 3. Now that we have our y value, we're going to find our x. So we're going to take our x equation, which is x equals negative 1/3 y plus 2, and we're going to substitute in 3 for the y value. So x equals negative 1/3 times, I'm going to write 3 over 1 plus 2. And the reason I did 3 over 1 is because we're multiplying by a fraction. So a fraction and fraction, you can see that the 3's cancel out. So you get x equals negative 1 plus 2, so x equals 1. So our ordered pair is 1, comma 3. That is your solution for the problem. When we go to example 3, it says x equals 2y minus 4, and we have negative 2x plus 4y equals 6. So again, they already told you what x equals, so we're going to use that for our substitution. So we're going to take our second equation, negative 2, and in parentheses, you're going to stick 2y minus 4 plus 4y equal to 6. We're going to use distributive property. So we get negative 4y, negative and negative makes it positive 8, plus 4y equals 6. When we combine our like terms, negative 4 and positive 4y, they cancel each other out, and we get 8 equaling a 6, which is not possible, which means this is a no solution. And because it's a no solution, we know we are inconsistent, independent, and parallel lines because of the no solution. Okay, example 4 says solve the system. We have 4x minus 2y equal to negative 6, and the second one says y minus 2x equaling 3. So we're going to solve the second one for y, so we're going to write it as y equals positive 2x plus 3 because we added the 2x over. Now we know what we're substituting in, so you're going to take your first equation, 4x minus 2, and in parentheses stick 2x plus 3 equaling negative 6. We are going to distribute. So you get 4x minus 4x minus 6 equaling negative 6. When you combine like terms, your negative and positive 4x cancel out, and we end up with negative 6 equaling negative 6. When you see the left and right equaling each other, this means infinite solutions, which means we are now consistent because it's one graph, but and it's worked. But the problem is we are dependent, not independent. We are dependent because it means we only see one graph line.